Moving on to particles and effects. First of all, two small things before we get into the particles themselves. We have two decals here. You can't have those on mobile. So decals on mobile will not appear, and even if you were to get them working, it's quite heavy. So I usually avoid any decals at all. And secondly, we have these volumetric lights here. You can see the light cone coming from the lamps. You should enable allow translucent selection. You're able to select them. These will not appear on mobile. If I enable emulation, you will see they will appear as default texture probably. And even if you were to set this up correctly, you would never be able to get the same kind of, they don't appear at all actually. Even if you were to set this up correctly, you would never be able to get the same kind of look. They would simply intersect with geometry. You will get hard lines. It will look very basic. You would be able to look against it and basically see the cone around you. It would look very bad. The only reason this works on PC is because of a complex material that's assigned to it. For example, the material will fade out dependent on the viewing angle. The material will fade out if it intersects with geometry. Since you can't do any of that, you should simply remove it. So I removed the decals and I removed the 6 light cones, volumetric lights. Then on to the particles. There's two main things that affect the performance of a particle on mobile. I'm going to make a temp particle here just to demonstrate some basic things. I'll just assign some form of material to it. Okay, so performance-wise, it's mostly the same as PC. It's not the number of particles that have a big impact. So if I were to spawn, let's say 100 here, it's not this that is slow. It can handle a fairly large number of particles quite easily. But what's slow is how much overdraw there is and how many pixels on the screen they occupy. So this right now is fairly light to render because it only occupies a couple of pixels on the screen, whereas the same particle right now is very heavy to render because it covers the entire screen. So it mostly comes down to that. How many pixels does it cover on the screen and how many layers are there behind each other? If you switch to shader complexity mode, you can see this is fairly heavy. It gets quite red. It's not that bad yet. But for example, the other particle here, the fire, this is extremely white. This is really, really bad. The red one is doable. That's the main thing. And it's also draw calls that has an impact. If a particle like this spawns a lot of sprites, that's still only one draw call. So every particle is one draw call. Every sub-particle system inside is another draw calls. So now this is 2 draw calls. It doesn't matter if it spawns 103 or 22 of them, this is one single draw call. The exception to that, however, are mesh particles. If I were to turn this into a mesh particle, spawning meshes, and let's select the mesh to spawn here. Well, for example, the plane or the glass dome, doesn't really matter, just an example. And I'll change the size because it's really big. So if I have a particle spawning meshes like this, every one of those meshes is into one draw call. So for mesh particles, it's not the same. For mesh particles, every mesh it spawns is one draw call. So this is now 22 draw calls plus 1 from the sprites. So it's 23 draw calls for the entire particle system as is. And you can see that's the problem for the fire here. The fire that I placed here is one of the fires from one of Epic's packages. I forgot where it comes from exactly. But this is made by Epic and it's very, very inefficient. That's why it's here. First of all, it goes completely white. It has a lot of overlapping layers. It's very dense and it has the potential of covering pretty much your entire screen if you were to stand right in front of the fire, as we do now. And on top of that, it's made up of a lot of mesh particles as well. If you open it up in the content browser, you can see just how many mesh particles it spawns. And you can see here it has mesh data, mesh data, mesh data, mesh data, mesh data, and then one sprite. So this is one draw call. This is 23, although the number here is not entirely accurate, but let's say 23, 5, 22, 44. So this entire particle here is pretty much 50% of the draw call numbers in this room if you were to optimize the entire room. It takes a huge amount of performance. So the only really way to salvage this fire, and I can show you actually what it would look like on iPad. That fire on iPad looks like this. And you can see I have 16 FPS currently standing in front of it. And it also just simply looks horrible to begin with. So the only really real way of salvaging this is pretty much starting over. So what I would do to fix this is very simply delete the smoke above it, because the smoke is too dense, it's too large, and delete every single mesh data. You should avoid mesh particles unless you really need them. They're about 10 times heavier to render than a sprite particle. So I would solve it by simply removing all of them, making a single new sprite particle system, and then we have a fire material over here, which is basically just a texture like this, and I will just play the animation, and this is a looping fire animation. And the material here is pretty much the same. A very simple material, set to translucent, unlit, two-sided, no base texture, so we should set that base texture there for a moment. And that's all you have to do, because it would automatically take the alpha from the texture, because the material is set to translucent. And you can see it's multiplied with a vertex color here, but you don't have to do anything about that. The particle system will automatically apply those settings to the mobile version of it. So just assign the base texture, and then assign this to the particle system here. Required material is that. Then it shows all of the frames at once. So if you scroll down and you look for the section sub UV, it says here sub images horizontal and vertical. Well, there's 4 frames in each direction, so it's 4, 4. And then interpolation method, linear blend. Now you can see it shows just one of them. And then you wanted to play the animation, so right click here, and it drops off the resolution a bit though. See if I can get it. Okay, right click the column here, sub UV, a sub UV movie for example, and here you can set the frame rate. If it plays slower, you can slow it down or speed it up. I'm going to make sure that it doesn't go up. So velocity, start velocity, and then max and min. So let's say 0 actually. So it doesn't really go up. It spawns all on the same location as well. I'm going to add a location cylinder. In the properties, location, start height, say 1 or 0 even. Otherwise it would start at different heights, and that's not very good for a fire. And the radius is a bit large, so let's say start radius 20 or so, so it's close together. Then we have that. It doesn't fade in, it only fades out. It's color over live that controls that, so I'm going to go for color over live added to the curve editor at the bottom, pressing this button. I'm going to hide the color line and simply focus on alpha over live. You can see it scales down. I want to have it go up and then down again. So I'm adding a point in the middle. I control click the line to get a point. Then the first point I right click it, set value, and I type 0. right click, set value 1. So now it fades in and out. Look in the level for a moment, it looks like this. It's much simpler, but this is gonna render much faster. Then I'm gonna press spawn, try to bring down spawn to 10. Try to use as few particles as possible. Not because it can't handle a lot of particles, but because it will reduce the overdraw. Looking shaded complexities, this simply looks like this right now. Whereas with 50, it gets redder. So the more particles you have, the denser it gets, obviously. And then one thing optionally to improve it a bit is I'm gonna do size by life, so I can make it grow as it gets older. So I've added that to the curve editor as well. I'm hiding alpha over life with the little yellow button there. In size, life multiplier, distribution, I set locked axis to XYZ. This will make sure I have just a single line in the curve editor to work with. And then I set the second point to 2. And now it grows. Fire is not entirely in the middle, simply moving it a bit. And also when viewed from above, fire gonna look sideways. So what I will do as well is right click again, orientation, lock axis, and set this to in orientation to rotate on Z. You can see then when looked from above, it looks like this. And that gives me a very cheap, very efficient little fire. You can also use the particle lot feature as shown all the way in the beginning. To remember, all the way in the beginning in the base system settings ini file, we had particle lot. Particle lot bias. I said all the way in the beginning that you could say, for example, on low end, for example, again, iPhone 3GS over here, you could add this line and set particle lot bias 1 on a low end device, or on simply all mobile devices. This is what we did for a mechanical actually. On a mechanical, we had it on 0 for PC, and on all mobile devices, we set it to 1. So particles always rendered lot bias 1 on a mobile device. And what this does is, when this is set to 1, it will use the first lot step of a particle system rather than the original. At the top here, you have a couple of lot settings. And if you set this, you can see it says 1 here, total 1. There's only one lot step, there's only the base step. However, if you were to add a lot after the current one, it will say 2 here. And then you can use the buttons here, left and right, to switch to the second one. Now I am in lot 2. Lot 1, lot 2. And if you now right click spawn over here, and you do duplicate highest lot or next higher lot, doesn't really matter, it's both the same in this case. You can see this now becomes normal color, you don't have this noisy overlay, and this now becomes editable. You can see if you click on the other ones, you can't change anything, it's all locked, it's dark gray. But by right clicking it and doing duplicate over there, you can now edit this. So if I now set the spawn count to 1, it now spawns just a single flame on low lot, on the second lot step. If we go back to the base lot, you can see the base spawns a lot more particles and the second lot step spawns just 1. So now on iPhone 3GS it would only spawn 1 flame, whereas on an iPad 2 it would spawn, 12 or so flames. But this is also a way of scaling the particles depending on what platform you're on. So what I would do here is set, for example, the second lot to 5 whereas the base slot, the first slot, has 10. So it halves the number of flames spawning. Then there's also an important thing which has quite a large impact on performance, and that's the bounds. And most people are not aware of this, but there are bounds for everything. The bounds are the bounding box. So every object in here has a bounds. It's how large it is. So if you do show, select a pillar over here, for example, to begin with, show advanced and then bounds, you can see the bounds of everything in here. Turn it off again. So now when you select something, you can see the bounds of the selection. See, there's this blue frame around it. That blue frame is the bounding box. Objects hide when you turn around, as mentioned earlier. So if I turn around, it will not render what's behind me. Also, the pre-computed visibility thing and the real-time occlusion that happens on PC, it also tracks the bounds. So if you can see part of the bounds still in view, like this, although I can't see the pillar anymore, the bounds are still here, it will still render the pillar. This is a problem for particles. If you have particles, for example, like my example particle over here, and you look at the bounds of that, and it quite quickly becomes obvious what kind of problem is. In fact, I can actually use the other one instead. I can take the original flame from the start package, just as a good example. So here we have the torch fire again, and as you can see, this is still the original one before we changed it with all the mesh data. This one will very obviously show you what happens. So at the moment this starts to play, you can see the box growing. It grows because it tries to fit around the flame, and then at some point it reaches maximum size. But that size that it reaches is much bigger than the actual flame and the smoke. See, this is the actual area that you can see, however the box is this large. That means that if I'm standing here and I can see a tiny part of the blue frame, it will render the entire particle still. And it also means that the computer has to calculate the size of the box the entire game long. It keeps refreshing the size the whole time, which is fairly heavy. And this has a fairly big performance impact on mobile. So what you should do is you should set a fixed bounding box size to all of your particles. You see here also this updates very continuously, and this adds a fair amount of overhead. It also adds an overhead to the PC, but the PC is powerful enough for you not to really notice. But on mobile you do. So edit the particle system. We open it up, and then in the particle system, click in the empty space next to the module over here, and you will get the main particle properties, which are these. And if you now go into the section bounds, you can see fixed relative bounding box, max and min. Set something there that matches the size of the particle in a fairly accurate way. Move it aside a bit so I can see it over here. And make sure you enable used fixed relative bounding box, otherwise it will ignore these settings. So I'm enabling it, and then we'll type, that's kind of large, so just see if you can estimate how big the flame is. I think it's 48, 48, minus 48 there. You can see now the box is this large. In fact, it should probably be 0 here, or minus 16. So try to fit the box accurately around the particle. Try to make it as small as possible, but not too small. If you make it too small, the fire might disappear before it's out of view. It might just clip away. Something like this will work. Also for the other two particles over here, you can set the bounds for that as well if they're not yet set, but I think they are because it doesn't update. But what I'm going to do is I'm also going to set the detail mode on these to high only. I can't do that on the fire because it would be kind of weird of having the fire not show up on low end. But these two particles over here are non-essential, so I will set both of them to high only. Also verify they have a max draw distance, which they have. They have a cached max draw distance, which is inherited from the curl distance volume. So that's correct as well. In a mechanical here, you can see that if you switch to shader complexity mode, we have no red, definitely no white, everything is green. The few particles we have, we don't have that many particles in general, the only real particle here, this one gets a bit white and red. That one is fairly dense, it's high detail only also. But other than that, all particles are small. And there is some wind here. But we try to reduce the amount of overdraw as much as possible. Also, if you look at our particles, we've done everything in the same way. Here we have the particle from the helicopter itself, which is beneath the little helicopter when you pick things up. This has a fixed relative bounding box set 64, etc. And it has two lots. If you step down to the next lot, you get a simplified version with only a couple of particles. Also, one thing that I would like to note here is I managed to get some fake bloom working. You can see it, for example, here. This is PC, of course, not entirely as it will look on iOS. But there is this kind of glow around certain things. For example, very obvious over here. That glow is not bloom, but it's actually a particle system. There is a particle right there. As you can see, just a dot, a gradient basically, that renders in front of all geometry. So it doesn't matter if it's behind or inside geometry. You can see it always renders through everything. Now this is not going to work for an FPS game, because then it would also render through the walls and through the next room and all that. But it does work for a side-scrolling game like this, because you never see it like this. You always see it from the side. And the way we did this is very simple. The particle itself is this. It's nothing more than a single sprite. See, it's a single sprite that's simply rendered and it's always there. It has a fixed bounding box set, but it only spawns a single sprite using the burst list. It has 0 for constant spawn rate. And the particle only loops once. So once it spawns this sprite, it will never disappear again. And then the way we got it to render in front of all geometry is by going into the material. And the material here looks like this. So on PC it's simply this. We have a texture which is solid white, but it has an alpha. It has this as alpha. So while RGB is solid white, the alpha is this. It has Force PVRTC4 enabled to get some better gradients, so otherwise it might get a bit blocky. And then here it's set to blend mode translucent, unlit, not two-sided because it's a side-scrolling game, but it could have been two-sided. And then most importantly, in translucency, it has disabled depth test enabled. By disabling the depth test, the particle and the material in general will always render through all geometry, so you get this kind of glowy feel that renders on top of other geometry. And down here at the bottom there's nothing special, it just has a mobile base texture. And that's it. Nothing else has been set.